Hi everyone, this is Sharan here. Today we are going to see three more topics related to statistics. So the first one is the empirical rule, and then Z-store, and then we will be going through the hypothesis testing as well. So let's see what is an empirical rule and then how it can be useful in a real life project. So here, as you see in the diagram here, empirical rule, what it says is in a normal distribution, so we do know that the center would always be the mean. The one would in the middle is always the mean. So in a normal distribution, there is about 68% of probability that the values would lie between one standard deviation away from the mean, which means that this is the mean here. So it could go either ways, like minus one standard deviation and plus one standard deviation. So there is an 68% of probability that the values would lie between these two values. So if we pick an example, let's say the mean of a particular sample, like a mean of a sample is 10, and then the standard deviation is 2. So what we are saying is there is a 68% of probability that the value would lie between 8 to 12, because 10 minus 2 and 10 plus 2, that brings it to 8 to 12. And if we move slightly further, there is about 95% of probability that the values would lie within the range of 2 standard deviation, which means that if we use the same example, there is 95% of probability that the values would lie between 6 to 14 in an example where the data is normally distributed and then the mean is 10. And if we move still more further, what it says is there is 99.7% of probability that the values would lie within the range of 3 standard deviation. So this is a standard rule that is applicable for a normal distribution. So how it is used in a real life is, for example, let's say we do know the data is normally distributed, and then we do have the mean of the particular population, and then we want to guess the probability of various values. We can use the empirical rule method in order to identify the probability of a data having that particular value. So that's about the empirical rule. Moving on to the second one is the Z-store. So as you see here, a Z-store. What Z-store tells us is, Z-store tells us how much away are we from the mean of the population. So let's say, for example, the Z-store for a particular example is 1.2. What it means is, it means that we are 1.2 standard deviation away from the mean. So here it says 1.2 standard deviation away from the mean. So here 1.2 standard deviation is the sampling standard deviation, sampling distribution standard deviation. So this Z-store value will be pretty much used in our hypothesis testing. So we will be seeing how it is being used in the hypothesis testing. So now coming to the third topic, which is hypothesis testing, which would use various concepts that we have discussed here. So in order to explain the hypothesis testing, what I am going to do is I am going to pick up a simple example. So let's say in an example where in a general population, the time taken to run 1 mile by anyone, like on average, is 12 minutes. And then what we are going to do is we are going to do a study. So we are taking a sample of 100 people into our study, and then what we are making is we are making sure that all these 100 people are working out for 30 minutes for 4 days a week for at least a month, for a month, let's say for a month. After 1 month's time period, what we are going to do is we are going to make all these 100 people to run again a mile. So now what we notice here is, we notice that for these 100 people, the average time to run 1 mile is now 10 minutes. So previously for the entire population, it is 12 minutes. So now all these 100 people, after a study, when they are made to run again 1 mile, so now the time taken to run is 10 minutes. And the standard deviation within our sample, let's assume that it is 2 minutes. So now what we are going to do is we are going to check whether whatever the workout plan that we have formulated, does it have an impact in reducing the time taken for anyone to run a mile. So what we are going to do is, in this particular use case, in order to test this particular hypothesis, we need to have null hypothesis and alternate hypothesis. So the null hypothesis will always be not having an impact. So in this case, we are checking whether a workout plan is having an impact or not. So our null hypothesis, what we assume is, we assume that it is not having any impact in improving the timeline of running 1 mile. So if it is not having any impact, what we do is we assume that the sample's mean time is equal to 12 minutes, same as the population. The alternate hypothesis is the work schedule or the workout plan that we have formulated does have an impact in improving the time period. So which means that the sample, the mean is not equal to, no longer equal to 12 minutes. So the first one is, we need to identify the sampling distribution standard deviation. So in order to identify the sampling distribution standard deviation, what we need to do is we need to divide the population standard deviation by square root of the sample size. So here we don't have the population standard deviation. We do know the population mean, but we don't know the population standard deviation. So what we assume here is the sample size that we are talking about is quite a good. It's about 100 people. So anything above 30 is kind of considered as a big sample. So now here we are assuming that the sample standard deviation is approximately equal to the population standard deviation. So we are using 2 minutes here, the same 2 minutes, which is the sample standard deviation, and then dividing it by the square root of 100, which is the sample size, which is 2 by 10, and then it will give us like 0.2. So now what we are going to do is, we do know the sampling distribution standard deviation. So now we are going to calculate the z-score. So how do we calculate the z-score? The z-score is, the population's mean is 12 minutes. And then we are saying that after the workout schedule or workout plan, the mean has reduced to 10. So we are going to see what is the probability behind reaching the value of 10 minutes. So what we are going to do is, we are going to subtract 10 from 12. So 12 minus 2, in order to see how much part it is from the, how much far it is from the mean. So what we are doing is, we are doing 12 minus 10 and then dividing it by the sampling distribution standard deviation. So which is 2 divided by 0.2, and then roughly it gives us the z-score as 10. So we do know that a z-score, z-score tells us the times of standard deviation away from the mean. So here when we say 3 sigma, it means that z-score is equal to 3, because it is 3 standard deviation away. So here when we say the z-score of 10, it means that it is 10 standard deviation away from the mean, away from the center. So now let's take a 3 sigma. So we do know that the probability of values lying outside 3 sigma is 100 minus 99.7, which is equal to 0.3 percentage. So which if we translate into value, it will be 0.003. So that's the probability. In our case, since the z-score is equal to 10, so what it will be looking like is, it will be looking like something less than 0.0001. So in general, so these are all the p-values. So p-value is nothing but the probability value, the probability of values falling, having that particular value. So here we see the probability is really low. So in general, while we doing all these hypotheses, the threshold that is set to the p-value is 0.05 percentage, 0.05, which is equal to p-value is equal to 0.05. So here, of course, our value is far less than 0.05, and hence what we are going to do is, we are going to reject the null hypothesis. So whenever the p-value, the probability value, is less than the threshold, which usually in studies it's been people will use 0.05. If it is less than this value, so then the null hypothesis is rejected. So which means that the alternate hypothesis is true. So here in this case, what it means is, it means that whatever the workout schedule or workout plan is being working in reducing the time taken to run a mile. So or it is improving the health of the people. So that is the hypothesis. So while covering the hypothesis topic, so what we have learned is, we have learned what is a null hypothesis. What is null hypothesis here? what is an alternate hypothesis, H1 is the alternate hypothesis, and how a z-store value is used in an hypothesis testing here. We have also covered what is the p-value, what is the probability value, which is here, and we have also covered what is the general threshold for the p-value, which is here, which is 0.05. So we have covered like various statistics topics in one example. Let's take an example, like let's take an e-commerce site as an example. So let's say the amount of time spent by someone from end to end. Let's say the amount of time spent by someone to complete a transaction is about 2 minutes and 30 seconds. So what we will use is we will use hypothesis testing to see if a new feature has been introduced, does it have any impact in maybe reducing the transaction time. So let's say that there is a feature which has been introduced in order to make the transaction faster. So now what we do is we don't release this to the entire population, whereas what we would do is we would release this to a smaller sample, let's say like few thousands of customers, and then we would measure how this is improving the overall time taken to complete a transaction. So let's say now for this particular sample, like to which the feature has been released, the time taken to complete the transaction, the average time taken to complete the transaction has reduced to let's say 2 minutes and 15 seconds from 2 minutes 30 seconds. So then what we do is we use these hypothesis testing to check whether the reduce in time is significant or not. So if it is significant enough, then it will be rolled off to the larger population. If it is not significant, it will not be rolled off to the larger population. So that's how these hypothesis testing will be used in a real life project. So it will be used in a lot of scientific experiments too. For example, if you are going to test a particular drug, whether the drug has an impact or not. So that's what the impact analysis will be made on a sample population. So based on the sample population study, if it is being proved that the drug has an impact, so then of course based on all the approvals, it will go to the larger population. So this hypothesis testing is quite popular in lots of use cases. So that's about it for today. So if you have learned something new today, please give a thumbs up and subscribe to my channel. If you think that this will be useful for any of your friends, please share it with them as well. Bye for now. See you in the next session.